Hello students, welcome back to the next lecture on this series of real numbers for your CBSE Class 10 Mathematics, right? So the very first chapter, real numbers, in the previous session of this chapter or the previous series of this chapter, we have learned how to prove root 2 is an irrational number, how to prove root 3 is an irrational number. So we try to prove that part using contradiction. So today what we'll do, we'll try to take another variety of the question. Again, in the last class I told you, this question is almost always asked every year for the 3 marks. So this is the second variety of the question where we have to prove that 2 plus root 3 is an irrational number. Okay. So for that, what I can do is, first I need to know one single concept. There are multiple ways you can prove this question, prove this particular part, but I'll tell you my own way of solving this problem. But before that, you need to understand this particular concept. If I add to rational number, if I add irrational number, you will get irrational number. Right? So this is the one concept you need to understand. Whenever you add a rational number to an irrational number, you get something called as irrational number, right? So first result, very important. Second result, this sign can be minus also. If you subtract irrational number from rational number, then also the answer will be irrational number. If you understand this one simple fundamental concept, you will be able to solve this problem. I am not trying to solve using the exact steps like taken in NCERT textbook or RD Sharma textbook. So this is my own way of proving this particular question. So let's understand it's very easy. It's very easy. So let's understand how we can proceed for this part. So first what I'll do in step 1, I'll first prove root 3 is an irrational. This is my step 1. And in step 2 of my answer, I'll just use this result. If I add 2, which I clearly know is a rational number, and if I add it to root 3, the answer will be irrational. This simple funda that we are going to use. Right? So let's start proving by root 3 is an irrational number. I'm erasing this part. Okay, let's start proving root 3 is an irrational number. So in the last class, we learned that I can say that root 3 equal to a by b, where ab are co-prime integers. इस पॉइंट पे ये सबको पता ही होना चाहिए, ए बी आर को प्राइम इंटीजर्स. ए बी अगर को प्राइम इंटीजर्स है तो मैं बी को उधर भेज सकता हूं स्टूडेंट. तो ये तुम्हारा ए बन गया रूट 3b. आई कैन स्क्वायर ऑन बोथ साइड्स, आई गेट ए स्क्वायर इक्वल टू 3b स्क्वायर. तो इससे क्या कंक्लूजन निकलेगा? मैं बोल सकता हूं कि इफ 3 divides a square, then 3 also divides a. Simple. Let's call this equation 1. Also, I'll write that a as multiple of 3k. This also we know. I can write a as multiple of 3. So it can be 3k. राइट स्टूडेंट्स, अब देखो इसको उठा के हमें इक्वेशन 1 में डालना है, ये भी हमने पढ़ लिया है. सो ये तुम्हारा इक्वेशन 1 हो जाएगा 3b स्क्वायर, और इसका रीजन आएगा फ्रॉम 1. करेक्ट? सो अगर मैं इसको सिंप्लीफाई करूं, ये बन जाएगा स्टूडेंट 9k स्क्वायर इक्वल टू 3b स्क्वायर, और b स्क्वायर इक्वल टू 3k स्क्वायर. करेक्ट? यस और नो? नाउ I can also use the CM theorem. If 3 divides b square, if 3 divides b square, then 3 divides b. Correct? So let's call this equation 2. So from 1 and 2, clearly 3 is one of the factor of a and b. So therefore 3 is one of the factor of a and b. but this contradicts the fact that A and B are co-primes. So we have to write that. But this contradicts the fact that A and B are co-primes. Right, students? A and B are co-primes. Now, thus, I can conclude thus by contradiction, we can say that root 3 is an irrational number. Right? So we have easily proved how like root 3 is an irrational number. So again, it was like a quick revision for you. Now, still our job is not done. I still have to prove that 2 plus root 3 is an irrational number. So for that, I'll write that sum of rational number plus sum of irrational number is always irrational number. Right, students? Irrational number. I can state the statement and I know 2 is irrational, root 3 is an irrational, 2 is rational, root 3 is an irrational, so their sum will be irrational. So hence proved whatever we wanted to prove, we have successfully proved this part. As simple as that, right? All right, students. So again, in continuation with this particular series of proving irrationality, in the upcoming lectures, we'll see the different variety of question. And once you cover those 2-3 standard varieties, you will be confident enough in proving those irrational question and get your perfect 3 marks, right? So see you in the next lecture. Until then, bye bye, students.